Hello everybody. This is my 11th vlog and I think I've done 10 out of 11 about math. That's cool with me if it's cool with you. So let's do it. Last time I was chatting with you guys about this, I was talking about kind of functions, different types. I brought up this word Boolean. I used the word true, false. I also talked about conjunction, which you could talk about as or. And today I just wanted to extend that a little further. But let's start with this idea that you can have something that is a type, and that type has rules, how you interact with it. And I will start with a Boolean, a true or a false. If you've done anything in programming or you've thought about computers, you'll come across the idea of a binary number, 1, 0. You could say that a 1 represents true and a 0 represents false. If you look at a circuit and you think about an open circuit and a closed circuit, an open circuit is one in which the way I'm thinking about it in my head is that if you've got sort of a circle of electricity and when it's connected, you have a light bulb, and when it's not connected, you don't have a light bulb. A light bulb it's not that the circuit, when closed, creates a light bulb. It maybe lights a light bulb up. So you have a circuit, if it's closed, the light bulb turns on. If it's open, it doesn't. It's basically saying you've turned the switch off, you've turned the switch on. And that's the idea of true or false, is that you have two possible options. You have one option or another option. You could win a game, you could lose a game. You could get a ticket for speeding, you could not get a ticket for speeding. Anything that you could pair up as an opposite, one or the other, is binary. That's a true or a false option. So, the idea that you have a proposition, which I said last time is a function that takes a statement and assigns a true or false value to it. You could be as elaborate and ridiculous as you want, but in the case of mathematics or logic applied to mathematics, you really are concerned with things that are actually true. Because from that actual truth, then you have statements that you can verify. For example, odd or even. Is a number odd or is it even? You don't really describe 2.5 as being an odd number, because if you think about the definition of odd or even, it means that any number that can be represented as 2 times a smaller number. 6 can be represented as 2 times 3, whereas 7 cannot. And that smaller number is a whole number, so 2 times 3.5 is 7, or 2 times 3 plus 1 is 7. So that's an odd or an even. So if a number is odd or even, then you've ascribed... I had to pause. My dogs were running around. Odd or even, if a number is odd or if a number is even, is verified via the definition. And that's kind of the thing in math, is you create definitions for other things, and then you can verify things with those defined things. I specifically use the word thing to represent something that's just repeated. So I said proposition is a function, gives a statement. You take a statement and it gives you a true or false value. So, for example, if you wanted to know 5 is even in the proposition function, well, that would give you a false. If it was 5 is odd, that would give you a true. Then we talked about another operator called conjunction, which means or. Now, how do we verify the truth or false value of an or statement? So, if somebody says, do you want milk or cream in your coffee, or do you want cream or sugar? Sometimes people have both. They have cream and sugar, or sometimes they have just cream, or they have just sugar, or they have neither. So, what is the truth value? So, conjunction is a function that takes 2 statements, 2 propositions, and it returns a truth or false value for the whole statement. So that's A or B. Now, how do we determine a conjunction of its truth or false value? That goes to the definition. A conjunction, an or statement, means A is true or B is true. So A or B is the statement. A is true or B is true. Sometimes it means A and B are both true. So if you have a statement, A or B, and A is true, then the conjunction is true. A is true, and under the definition that it's true if A is true or B is true, meaning that either A or either B can be true. So if he says, if your propositions were 5 is even or 5 is odd, well, 5 is odd is true, so that means that B was true. So you have a possible option where A is true and B is false. You have an option where A is false and B is true. In both of those instances, that conjunction will yield a true value. Or you have the instance, and I'm using the word or again, you can see how we use these words in our everyday language, and at the same time they can be formalized into a mathematical expression. You can have the situation where A and B are both true, in which case the conjunction is also true. Now, that leads us to this other idea that you have an inclusive or an exclusive or, meaning that are you saying that it's true if both of them are true, or it's not true if both of them are true? And that's a topic for another time. Then you finally have the last option in which A is false and B is false. That means that the statement, the conjunction, is actually false. So you have 3 ways that you can get a true value for an or statement. And the and statement is very similar, except that you have 3 ways in which a statement is false and 1 way in which it is true. So if you're following along, I'll talk about the and statement next time, and I'll verbally go over how this happens. The idea, though, is that you start building more complicated expressions. What if you had A and B or C? How does that play out? And there are so many different complications that you see that talking about math gets you only so far until you get to the point where you're like, well, I need to discuss this a lot more concisely in a way that we can get. When that happens, that's when it's important to introduce symbols. Up until 1950s, 1960s, there was a man named Paul Samuelson in economics who said economics needs to be mathematical. Until then, mathematics was discussed verbosely, like in words, and it was very complicated, and people could argue over the same point. The idea is that if you have a mathematical expression, you hope to eliminate the situation in which 2 people could argue vehemently against each other, only to realize that they were on the same side because maybe the argument was so complex. That's one of the ideas of math, is it hopes to abstract away from the world to make a model of something that is so complex that you could never figure out. In order to figure out, you might need to recreate the thing exactly. But if you take a model and you try and simplify things, hopefully you can come up with some predictions that are on the right track. From that, there's this idea that if you're making a model of something in math, and it all goes back to understanding the semantics, understanding the meaning of the situation in which you want to make a model. It's always going to be wrong, though, so you're always approximating something of life, you're simulating something of life, but you're not actually copying life, you're just making some smaller schematic. And that's really interesting because that's how so many things are being done now, whether it's statistical modeling or mathematical modeling, or it's done in computer science. We're all modeling reality in different ways, but we're all wrong, and we all know we're wrong, but we're trying to make good guesses, and I think that's really interesting. I'm going to leave it at that with the math. I love talking about this stuff, even if it just helps me say this, and then you guys listen. If you like it, definitely subscribe, hit like. I'm really using this as the beginning of me just getting comfortable with talking to the camera, being comfortable with expressing ideas, and as this emerges into something new, then I want to incorporate more graphics, whether it's like full-blown animations, or it's, you know, like 3 blue, 1 brown is a great example. I'd love to just be doing animations like that, which actually just uses Python. Or like Khan Academy, where you have some sort of black screen and you see the stuff being written digitally. Or slides, happily do presentations. I think that's where I want to take this. But right now I'm just using this as practice and uploading them for people to see. So thanks so much for listening. Like, subscribe, hit the notifications. I'd love to build a community, build just a group of people that want to listen or want to contribute. Thank you. Okay, see you guys.